Hi, welcome to OpenLC Solutions. Today we're continuing through 2014 Ordinary Level Paper 2, and this is question 3, which is all about coordinate geometry of the circle. To start off with, they give us a circle named C with a particular equation, and they're asking us to write down the coordinates of the center of the circle, and they're asking us to write down the radius length of the circle as well. So you might remember, or you can look up in your Formula and Tables book, that the equation of a circle is given by x minus h squared plus y minus k squared equals or squared. So when you have an equation in this form, this is a circle where h and k are the center. So this is center, hk. Those are the coordinates at the center. And the radius is 4. Now we actually have it in this format, we just need to make sure we get the signs right. So the center, also known as A is what they call it, is going to be a minus 2, because remember the formula has to be minus h. This is a plus 2, so we have to actually change it to be a minus 2 to make that work out. The y coordinate of the center is given when it's y minus k, and this is already y minus 3, so we don't need to worry about the sign. It's just going to be a plus 3. The radius you determine from the number on the right hand side. It is the radius squared, so the radius squared is 100 in this case. The radius must then be root 100, so it's the inverse operation of squaring, which gives you 10. The second part asks us to show that this particular point, minus 8, 11, is on this circle C. To prove this is the case, you take the coordinates, call them x and y, and you substitute them into the equation of the circle. And if it's on the circle, you will end up with 100, because that's what this turns out to be on the right-hand side of the equation. And this doesn't just work for circles, by the way. When you're doing coordinate geometry of a line, you will also be able to prove the points are on the line by substituting them in the same way. But back to the circle, we substitute those in, so we end up with minus 8 plus 2, and that gets squared. Instead of y, we're putting in 11. The minus 3 and the square are already there. This turns out to be minus 6, which gets squared. Then 8 gets squared. That's 36 plus 64, which is 100. And that's what we're looking for. Any time you put in coordinates and you end up with 100, that means it's on this circle C. The first bit of part B asks us to find the slope of the radius A to P. So we need to know the coordinates of these. A was minus 2, 3. P was minus 8, 11. And to find a slope, you need the slope formula, which is y2 minus y1 over x2 minus x1. So let's pick which one is which. It doesn't really matter. Let's say that's x1 and y1. There's x2 and y2. Now we need to just substitute those in. y2 minus y1 becomes 11 minus 3. x2 minus x1 becomes minus 8. It's a minus, then a minus 2. That's 8 over, this is minus 8, it'll end up being a plus 2, which is a minus 6. So the slope is minus 4 over 3. The next part asks you to find the equation of t, which is the tangent to C at the point P. So we're going to need to remember P is minus 8, 11. From the last part we know that the slope of AP is minus 4 over 3. Now because this is a tangent to the point at P, what you have to remember is the tangent and the radius at a particular point are perpendicular to each other. And you should also remember how to find the slopes of perpendicular lines. To find the slope of this line T, because it's perpendicular to AP, all we have to do is take the slope of AP, invert it, so make it 3 over 4, and change the sign. It's currently a minus for AP, so that means we make the slope of T a positive. So we can just leave it as 3 over 4. You can call it plus 3 over 4, but it's unnecessary. Now we can use that information to find the equation of t, because we know the equation of a line is given by this formula, y minus y1 equals m times x minus x1. Since it passes through p, that's going to be our x1 and y1. So we end up with y minus 11 equals, the slope is 3 over 4 times x minus, it's going to be a minus 8. So that is y minus 11 equals 3 over 4 times x. This is a plus 8, and 3/4 of 8 is 6. You could leave it like that, but they want the simplest answer possible, and it's kind of typical to represent it in a particular form where you've got y equals something times x, and then you've got a constant afterwards. So this is going to be a 6 plus an 11, which is 17. The last part of this question tells us there's a line k which is tangent to the circle at a different point q, and it also tells us that k and t are parallel to each other, and we have to find the coordinates of q. So let me just draw out this situation. There is our circle. We know the center is called A, and it's at -2, 3. We have this other point P over here somewhere. I'm not going to be hugely accurate about this, which is at -8, 11. And there's a tangent to the circle passing through that point P, which goes like that. Now it's telling us that there's another point Q, and there's a tangent passing through this point which is parallel to T. The only way that happens is if P and Q and A are all in the same line, or if P and Q are opposite ends of a diameter. So Q is over here. That's the only way you end up with a parallel slope, and so this line is going to end up something like that. Now you can see the two lines are parallel to each other, and so that's what we need to find then is this point Q that has this tangent passing through it. So what we know about parallel lines is that they have the same slope. We can go into this whole thing about trying to find the equation of the line K and try and work out some points on that fit onto the circle, but there's a much quicker way where you just need to say, because these three are all on the same line, and because the distance from P to A is the same as the distance from A to Q, because they're both radii, you can actually just use a little trick from transformations. So to go from P, which is -8, 11, to A, which is -2, 3, you need to add 6 to the x, and you need to subtract 8 from the y. To go to Q, you need to do exactly the same thing. So if you add 6 to the x, and you subtract 8 from the y, you're going to end up with a 4 and a -5. And that's all you need to do. It's just a straight up transformation geometry question. As I say, it's entirely possible to do this with like finding the equation of this line, or you could find the equation of the diameter here and try and find the points based on that, but that's way overcomplicated. You'll get the marks for it because it will lead you to the right answer, but it's just totally unnecessary. All you need to do is this transformation. So thank you very much for watching, and hopefully I'll talk to you again in the next episode.